Right, okay. So, anyone need me to do number 12? Anyone need me to do number 13? Anyone need me to do number 14? Yeah. 14, yeah. Right, okay. Pen. Right, so page 215, so number 14. Given two events, A and B, are such that probability of A and B, that's A intersection B, the two of them happening at the same time, is equal to the probability of A multiplied by the probability of B. State what you can say about events A and B. They're independent, right? That's the formula for independent events. Okay, so if event A is obtaining a 6 on a single throw of a dice, suggest a possible description for event B. So you suggest something that doesn't affect 1. I can't think of anything that would affect 1. So throw another dice, right? Okay, toss a coin, pick a ball out of a bag, something that doesn't affect it. Nothing will affect throwing a dice when it's done, right? Okay, is that alright? Okay, part 2, given the two events C and D are such that C or D, right, okay, is equal to the probability of C plus probability of D. State what you can say about events C and D. They're mutually exclusive, right, they can't happen at the same time. Okay, that's the formula for mutually exclusive, because if they're not mutually exclusive, you have to minus, that is minus P, or the probability of C intersection D, it would be onto the end of that. But the fact that there's no intersection, they don't happen at the same time, right? So they're mutually, write down the values of probability of C and D. The probability of C and D happening at the same time is 0, right? They ain't going to happen at the same time, they're mutually exclusive, right? We came across that formula back in probability 1, okay? Is that right? Is that okay, Summer? Right, 15, anyone? 16? No, we're all good? Right, great. Then we went on to the next page and I asked you to do, I can't remember, 4, 5, 4 as far as up to 9. Number 4, does anyone need me to do it? Number 5? No. Number 6? Yeah. Part 2. Right, so number 6, in a class of 24 students, right, there are 40 boys and 10 girls. In a particular week, 3 students celebrate their birthdays. What is the probability that these 3 students, right, have their birthday, or 3, you've that done, have their birthdays falling on different days of the week? So it's not about selecting boys or girls anymore, it's just you're going picking 3 students from the class. What are their chances of having their birthdays on a different way? So the student number 1, student number 2, and student number 3. So student number 1, you're going to pick them and say, what day of the week is your birthday on? So they can say whatever they want, right? Okay, we don't care what they say. So they have a probability of 1, right? Because they can say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, because they're first, so we don't care. Student number 2, they can say any day except the first day that the person said. Isn't that right? So they have a choice of 6 out of 7 days. Isn't that right? What about the third person? 5. They have a choice of 5 out of 7 days. Because they can't say what this person said, they can't say what this person said. So that would be 30 over 49. Is that okay? Right. 7? Anyone? No? 8? Yeah. Right, okay, so number 8, duster. So number 8 reads, a class of 16 pupils consists of 10 girls, 3 of whom are left-handed. Right, so we have 16 pupils, we have 10 girls, and we have 6 boys, obviously. Right, so, and of the girls, there's 3 lefties, so that means there's 7 right-handed, and of the boys, there's 1 lefty and 1 right, that means 5 right-handed. Is that okay? Right, 2 pupils are chosen at random from the class to act as prefects. Calculate that the probability, so we're looking for probability, that the chosen pupils will consist of one girl and one boy. So if we wanted 16, choose 2. So 16, choose 2. All the different ways you can choose them without restrictions would be 8 15s, 120, is it? Would that be right? Okay, so there's 120 different ways you can choose them without any restrictions, right? Okay, but they say one boy and one girl. So out of 10 girls, you have to choose 1, and means you multiply. Out of 6 boys, you have to choose 1. So how many different ways can you do that? 60, isn't that right? So then the probability, you have 60 chances out of 120 to choose 1 boy and 1 girl. So that cancels down to a half. Is that alright? Sorry. Is that okay? Right, okay. Next part, that was part 1. One girl who is left-handed and one boy who is left-handed. So again, one girl that's left-handed, there's 3 left-handed girls, you have to pick one of them. And means you multiply, there's 1 left-handed boy and you have to pick him. So there are all the different ways you can pick 1 left-handed girl, 1 left-handed boy. So that's 3, and it's out of the total number of ways you can pick any 2 students is 3 out of 120, so that cancels down to 1/40. Is that okay? Yeah, I'll take that as a yeah, nobody's talking. Right, okay. 2 left-handed pupils. So basically, you're putting all the left-handed people together. There's 4 of them, and you're choosing 2 of them. Right, so it doesn't matter whether they're boys or girls, you're just going to lump all the left-handed people together, and you're going to choose 2 of them. So 4 choose 2 is 6, and then the probability of that happening is 6 over 120, which is 1/20. Is that okay? And then part 4, it says at least 1 pupil who is left-handed. Right, now the best way to do that is 1 take away, no left-handed. That's the best way to do the at least. So if you say it's 1 take away, no left-handed. Okay, so no left-handed, right, would be, there's 7 right-handed and 5 right-handed, so you're only choosing from them. So that's 12, choose 2. Is that okay? So they're the right-handed people. 12 choose 2, which would be 66. Right? So that's the probability of that is 66 over 120, and 1 take away 66 over 120 is whatever it is. 66 from 120 is 34, and 20, 54 over 120, which cancels down to whatever. Is that okay? 9 over 20, I think. Is that alright? So, you know the at least number, at least girls, it's better, the best way to do at least is 1 take away none. Right? Okay? And none take away, none is if there was no left-handed people, so that means you're only picking from the right-handed people. So there was 12 right-handed people, I want to choose the 2 from that, so that's 66. The probability of picking those right-handed people is 66 over 120, right? And 1 take away that is the at least 1 left-handed. Is that okay? So you know those at least questions, always do none, 1 take away none. So if there was at least 3 boys, say, or sorry, if there was at least 1 boy, you do 1 take away no boys. Okay? Right? If it was at least 1, I don't know, blue ball, you do no blue balls. 1 take away no blue balls. So, no, you have to do those separately. If it was at least 8, or it's only at least 1 that you can do 1 take away. None. Is that alright? Okay? Right, are we okay with that? So that was number, I don't know. That was number 8. Number 9? Right, okay. 3 dice are numbered 1 to 6 are rolled. Okay. One dice is fair and the other are biased, so that for each of them a 6 is twice as likely as any other score. So basically, normally we have 6 numbers on a dice, and to get a 6 you have a 1 in 6 chance. Would you agree? Right, okay. Then we have a dice where basically there's 2 6s and one other number. So for the biased, so this is a regular dice, and for the biased dice there's now 2 6s and one of every other number. So how many faces are on the dice? 7. And what are your chances of getting a 6? 2. So you have 2 over 7. So everything else has a 1 over 7 chance of being picked. So the chance of a 6 is twice as much as the rest, isn't it? Because that's the only way that you can, the 6 will be twice as likely. There mightn't be 7 faces, there could be 14 faces, there could be 21 faces, we don't know, right? We just know that the 6 is twice as likely, right? So here there was one number 6, and one number 5, and one number 4, and one number 3, etc. So 1 5, 1 6, 1 5, 1 4, 1 3, 1 2, 1 1, right? Okay, over in this other dice it tells me the 6 is twice as likely. So here you have one chance of getting all those numbers. So you have to have 2 chances of getting a 6 for it to be twice as likely, isn't that right? So that makes 7 phases. And 2 of them are 6. Okay? Takes a bit of thinking about, right? Okay? So there's a 2 in 7 chance of you getting the, on the biased dice, of getting a 6. Okay? So then we have to go, they're going to be thrown 3 times. Find the probability of rolling exactly 2 6s. Right, so if we say we get, so regular bias, so we have to get 2 6s, okay? So if we get a 6 on the regular, so a 6 on the regular dice, a 6 on the bias dice, and no 6 on the bias dice. Is that right? But, or, what could we get? We could get a 6 on the regular, no 6 on the second bias dice, couldn't we? No 6 on the second bias dice, and then a 6 on the last bias dice. Okay? So again, I have 2 6s, right? Or, right, I should have started that further over. I'm just going to rub that out so I can get it all in one straight line, because if it's on 2 lines it'll look a bit weird. So you're going to get 6 on the regular dice, you're going to get a 6 on the bias dice, and then for the third bias dice you're going to get no 6 on the bias dice. Is that alright? Or we to take into account the different orders. So we could get a 6 on the regular dice, then we could get no 6 on the second bias dice, and then we could get a 6 on the bias dice. So I still have exactly 2 6s, don't I? Right? Or, tell me, what could I get? No 6 on the regular dice, and then I could get a 6 on the bias dice and a 6 on the bias dice. Right? I'm still not going to fit it on the line. Or, there's one more way. No, there isn't. Right? Because the other way is no 6, 6 and a 6. So that's all the options, isn't it? Is that alright? Okay, so 6 on the regular dice is 1 over 6 chance. And a 6 on the bias dice, that's a 2 over 7. And no 6 on the third bias dice, what would that be? 5 over 7. Or means you add, right? Then we have a 6 on the regular dice, right? No 6 on the bias dice, that's 5 7s. And then we have a 6 on the bias dice, that's 2 7s. Or means you add. So we have no 6 on the regular dice, that's 1 over 6. Then we have a 6 on the bias dice, which is 2 over 7. And then we have another 6 on the bias dice, 2 over 7. So then you work up all that and add them up and you get your answer. Is that alright? Takes a bit of, there's a lot of thinking in that one. There's a lot of probability in that. Right. Okay, that was it. Was it number 9? Right, so the last we're finished the chapter, right? Okay, so for today we're going to start the core exercises, and for tomorrow and Friday I had them printed out, I just don't have them photocopied. I have all the probability questions printed out for you, so we're going to do those tomorrow and Friday. Is that right? Okay, so today we just start the core exercises, the core revision exercises. Okay, I'll put them up in Teams for you right now. Right, okay, and then you can do those. And as I say, tomorrow I will have exam questions photocopied for you to do tomorrow and Friday. Right?